Hey there, happy Monday. Recently saw that there's been more of a conversation being had on Retrieval Augmented Generation, or RAG, uh, particularly as more of, well, really every industry, but medicine, medical education specifically, are starting to, or at least some folks, ask this question of, okay, what is RAG? And people throwing out different opinions on it. Wanted to go straight to the source and make it more of a deliberate dialogue based off of clinically significant evidence, right? Because it's not just about, oh, this publication over here said X. This is about something really looking at evidence that is validated, put out again and again and again and again in every possible way to then give us good, consistent, reproducible, reliable result. And so, firstly, the question is, what is retrieval augmented generation, right? And for that, we're going to go make things nice and simple. So, for orientation, this is you, or me, or whoever. And we put in a query or a question. Think about you using ChatGPT. That is a question, a query of, hey, do X. So too is Google of whatever you search for. Then there's a retriever that ends up going through and searching a data source, and that can be everything from a PDF that is right there that you give it, to it searches the internet, to it only searches certain intranet or a local network that isn't connected to the broader internet. Wherever it is, it goes to a source that it is pointed towards to retrieve that information. You'll hear a lot of folks talking about what are referred to as vector databases. At a very high level, just think of every model that is using retrieval augmented generation, or RAG, is giving information that has gone through a validation process and really retrieved your answer for your query based off of a deliberately developed data source or data process or retrieval process that was programmed into it. Just think of every time you Google something, you get the results based off of, well, what the Google search algorithm looks for. The entire market of search engine optimization, SEO, is based off of understanding that retrieval process to then get the result. So really, when we think of RAG, just think of you are now implementing a search process, a Google, if you will, although, right, Google does not have that ownership of RAG. Even really, they're not the ones that came up with any of that. But for the purpose of this conversation, it is your query going to a search that is defined by the model and / whoever company made that model. So if it's, say, Gemini, then yeah, it probably is going to use Google, because that's who made Gemini. If it is Meta, maybe it uses Microsoft Bing because Meta and Microsoft have a good partnership. But they probably also use Google too, because that's what most people use. Google has dominance in the search engine market, so it just makes sense. And then down here, so once it goes there, so you question your retriever, and there's multiple ways of this. This can be everything from, let's say that you're writing in Python, which is a programming language that is the most common and most honestly popular and used programming language for generative AI. So in that Python program, or with Python, you can use different tools within Python to do a request to the internet. You can have it reach out to specific sites, like say PubMed. There are specific tools to reach out to PubMed specifically based off of queries, and then it will populate your answer based off of that because you point it to PubMed or Yahoo Finance or whatever. And so it goes to the LLM or the large language model or the generative AI model slash small model. I mean, there's more than just the large models out there, but to then give the response. So retrieval augmented generation, it's a very broad term, and all it really amounts to is, does your AI model, your generative AI model, use more than just its training to answer something? Is there a check on it? I mean, every time a clinician or a student doesn't know something, what do? Do they guess with the potential to hallucinate? Well, no. They go to a trusted source. They go to something, whether it's Clinical Key or UpToDate or Dynamed now, or Amboss or whatever. They identify that there is a gap in their knowledge to a question somebody asked. Let's say this is an attending asking a query to a student. Hey, what are the indications for cholecystitis? To conduct surgical intervention versus relying on medication versus just observing, because, right, it's a very common pathology. So that student, if they don't know, will search for the information, and the ones who have, say, experience in that will look at more up-to-date, better references. But really, that information on what the right thing to do, it depends on the person. I mean, by and large, if it's a clinical process, particularly at a hospital system, you will want to look towards a trusted source, perhaps like a clinical practice guideline of what that is from the American Academy or the American College of Surgeons, or if that hospital system has its own protocols, looking towards that. At minimum, looking towards the textbooks that refer to clinically based anatomy to then speak towards what randomly controlled trials have been done to support the clinical practice guidelines, or at least the indications for the thresholds to prompt intervention, right? It's about identifying whether it's a person or an AI model, where their gaps in knowledge are and what data sources they go to rectify that. The way you do RAG is, there are any number of ways, but just to know that it really is the industry standard and the right thing for implementing it. So, and right, because we have here the New England Journal of Medicine AI with a paper that was published in January of this year on that specific topic with this model, Almanac, or framework, excuse me, Retrieval Augmented Language Models for Clinical Medicine. So the course, right, because this is New England Journal of Medicine and this is a newer paper, this paper is not necessarily accessible, or at least I don't subscribe to that, so I don't have access to this one specifically. However, because the authors were very generously put this into a preprint, we have the ability to see it from there. So again, this is PubMed. regular PubMed, and right, this is being part of the NIH / the Department of Health and Human Services, and has a PubMed ID, PubMed Central ID, that's the PMC ID, and a Digital Object Identifier, DOI, all of it to cue that this is legitimate. And of course, we also see Stanford Med, Stanford University, Penn Med. I mean, I'd call that pretty valid. And they note here that there's an update in the New England Journal of Medicine, AI. And so, right, it says we can go ahead and see that. Free full text. Oh, let's see. Oh, hey, hot diggity daffodil. Okay, so I strike my original statement of not being able to access it, right? So that's great that we actually have that. And because we thought to look through PubMed and knowing the process of preprints versus that preprints are part of the PubMed ecosystem at this point. Due with that NIH pilot that was highlighted in that. Where is it? Come here, you. Here we go. Right, and so this has been established for quite some time as papers from a preprint server, this one being Research Square, are up on PubMed and then annotated as such, right? So at a very high level, because we don't want to go into all the deep nerdistry here. So this is the PubMed article, and this here is the paper when it was on Research Square. So here, right, we have the ORCID, which is great for being able to showcase having a reliable, transparent view, and a original research ID to individual identify. And originally this was posted on May 2nd of 2023 with the Creative Commons license. But so same right here, putting out, and it's great to see that progress and the fact that preprints, they may poo-pooed and some by some folks, understandably so. I see why. It's also free. Now, granted, for a lot of preprints like Archive, you have to be endorsed by somebody or submit paper that gets accepted, and that's your ticket into the Archive ecosystem. But once, as long as you're able to get that, it is free to publish too. And so here we talk, and again, just hitting some of the high points here, just because there's a lot of terms here that are used within the industry and academia, and want to ensure that folks are getting an understanding on that. So when we talk about zero-shot capabilities for an AI model, an LLM, which, and for in case you're able to say AI model, I understand we're going to be talking about large language models. Just keeping it simple. It's that it can answer from just first time. So you put in a question and then it answers it, versus multiple shots, or if you need to prompt it and get more than just the one initial prompt. So right, it talks about auxiliary data here being good, there being a tool within the toolkit that they can end up using. Here, let's yeah, there we go. I mean, my eyesight's terrible, and it's, these big bad boys here. But so tasking a panel here, right, talking about what they overall went through, and they use medical guideline and treatment recommendations, and they compared it with ChatGPT-4, Bing, and Bard. So ChatGPT-4 has gone through a few iterations since then. Not sure what version they went through, but we'll just say GPT-4, so from OpenAI. Bing uses GPT-4 as well. Well, and depending on the subscription, it either uses GPT 3.5 or GPT-4. And right, it's ultimately, when you think of Bing and having AI, remember that Microsoft has a 49% stake within OpenAI, and it really is all of OpenAI's models, or their GPT is what powers a lot of the Microsoft ecosystem. Now, Microsoft, being the smart business that it is, also has a playground and welcomes models like from Mistral, from Cohere, from really a lot of places, that you can find accessible with them. And them and other folks, the other major players in the industry, are not interested about winning. It's about creating the ecosystem that everybody else plays in. Because if you create the ecosystem, you create the playground, and you're one of two or three, well, then suddenly you don't have to be in the knife fight. You can just have everybody come to you, and right, so you're not constantly having to run around because people come to you. And that's just smart. It's Peter Thiel 0 to 1 of you don't try to compete, you just create the space, right? And how understanding that this technology is what it is, they want to partner and amplify folks who want to create great things. So it's great. All right, so LLMs with access to domain-specific corporate, so just information to be effective in clinical decision making. Carefully testing before deployment. Yes, 100%. So, in going through this, let's see. Yeah, it's about the fact that hallucinations can occur. And again, think of AI models as I think Iman Mustek, the former Stable Diffusion Stability AI CEO, and just think really a great pioneer in the space pertaining to the open source community. Think of these AI models as graduates, as grad students. What do grad students do? Well, they've got a decent knowledge, but if you ask them something, they're trying to impress their principal investigators, their attendings, their whoever, and so they may infer and come up with the wrong answer, what we can see as being hallucinations. It is whether people are models, coming up with the best possible answer with the information they have available. So what does the PI, the attending, the mentor do typically when they see a young learner who does not have that knowledge? Hey, go look this up. Go augment your retrieval so you can generate a better, more thorough answer that is sourced reliably. And typically something like, oh, look in this textbook, look in this, go to PubMed, go to, wherever, as long as it's a shared source. But that is also dependent on the institution, on the person, on the training they went through. And you ask a OB-GYN versus a general surgeon versus an orthopedic surgeon, they'll typically all probably say netters for anatomy, but if you ask them about the different procedures, they're going to be different. For an orthopedic surgeon, that might look like Hoppenfeld's. For OB-GYN, that might look like, Tillin's. But there are going to be very specific texts, very specific domain expertise dependent on the domain. Surprise, surprise. So the fact that they call this Almanac, right, is speaking towards the fact that we identify and package up trusted data sources to help us navigate. And so, all right, whether it's search engines, medical databases, calculators. Hey, sometimes 4 + 4 is hard to do. But it's about aligning data source to domain so that really can get that high quality answering with the citation. And whether it's in text or otherwise, it's nice when it's in text, but ultimately to me, maybe this is N of one opinion, I think the most important is to know that you are pointing that the trusted, or what you're pointing the trusted data source to, or rather the retrieval to. Who makes that choice? What is valid? And finding that balance between being prescriptive of like, oh, we think these are valid. It's like, okay, sure, but there's no 100% proof solution. So it's about having multiple trusted sources that can act to help somebody with making the right decision. So going through and Yep, right. Talking about the panel, lots of experience. Talking about transformers. This is the T in ChatGPT. And we also have ones like BioGPT, Cybert. Yeah, but it's interesting. Folks don't really consider the fact that the transformer architecture that was like kind of made everything go explode in the generative AI space. That was made by Google. It was a 2017 paper called "Attention is All You Need," which is you need more than attention. But the fact that there's similarities between models by Google and the transformer architecture that they made, yeah, they made it, so there's going to be similarities, but there's going to be plenty of differences, and there are multiple different tweaks, different things that go on with transformers. So it's not something to really get lost in the weeds on, but it is important to consider where original IP came from and what models are made by who and how. So interesting that it's not talking about not a novel concept. It's like, well, yes, right, but it's what we're finding is novel is the way now that people are finding a way to do it without being super costly, because that's important. And I think the authors do end up highlighting that as well. So, and again, it really boils down to finding that alignment of you can have access to trusted data sources reliably that aren't going to just completely bankrupt you by getting access to that. So it's how do we do that? Well, there's already a number of data sources on, or data sets, on Hugging Face. And spoiler alert, the authors here, I think greatly, they acknowledge and have collaborated with Hugging Face specifically for this paper that was published. And so this is, I know, right? Hugging Face, it's just funny to say every time, but to understand that like these data sets here, Multimed QA, Med MCQA, PubMed QA, these are all available on Hugging Face. Can't remember the last time I saw Multimed QA, but I put a previous video, Med MCQA, PubMed QA, right? But even those, that's a lot more of the reinforcement learning with human feedback, because it's more just getting it through. We're finding now that there are more efficient ways of training a model, and the way you train it, and what makes it more efficient is that you curate the data in a way that is conducive to more being aligned to preferences. So it's like question-answer pairs. The difficulty, though, then is that you, or typically a person / later with AIs synthetically amplifying it, there is a mindfulness of a person saying, hey, this is the right way to ask this question. Like, what are the indications for surgical intervention for cholecystectomy? And with that, we find that is most efficient, and getting the best efficient for training, and so you can train on less hardware for less amounts of time and still get good result, is it's being more specific. So the reason it's quality is because it's about the domain expertise to understand all the possible nuances that are important for that, both for the positive, so what the right answer is, and for the negative of what the wrong answer is for each and every one of those question-answer pairs. And so it's important in terms of what that can look like, because that's to not get down to that level of detail, the right amount of detail, right? Not just about making it longer and longer and longer, but just what are the most important things to consider. That is honestly an ethical responsibility, because that is a person then stating, or multiple people working on a model stating, hey, this is the right answer. These are the most important things. And while the evidence is a little bit more straightforward for something like indications for acute cholecystectomy, the acute removal of a gallbladder, people are going to ask it all sorts of questions. Things like, insert hot topic here in this 2024 year as an election year. and we'll just leave it at that. But it just something to be mindful of for this. So, and they here curated, or they address these shortcomings here. They talk about this benchmark. And yep, so going through, they compiled 314 questions, right, based off the different domains, and they have this nice diagram, like, so, right, query, LLM will rephrase it, right, because an LLM, it doesn't know words, so it does what's called tokenization, which means that it takes the words and converts them into numbers. So the word cat and the word dog and the word relationship are all a token. And yes, there's, right, for simplicity's sake, we will say one word equals one token. Then it further takes those tokens and turns them into what are referred to as embeddings. And embeddings, think of as a representation of whatever that word is, whatever that token is, in a, what's the word I'm looking for? I know, right? My goodness, maybe I need some retrieval augmented generation. Think of it like this. Each one of us has memories that are imprinted, and when we hear a word, when someone's talking to us, and says the word dog or cat, our brain, from our ears, the sound goes in, turns into electrical signals, and processes, and it then within our brain, somewhere in there, right, amorphously, or just right within all those different neurons, there is a connection of neurons that brings about the visual image, and as we're thinking about it, of a dog or a cat. And it's not necessarily like physically somewhere in there, but it's the fact that connections can be made so that we can then represent that and think about it. So too, when a model has a word that's tokenized and then turned into an embedding, it then creates that representation of, okay, up here in this space, so think of like one of those X, Y, Z axes from your geometry class. Oh, I know, right? But in that, and it's multiple dimensions, more than just, say those three, but a location of, okay, this is where dog is at, and it's like dog minus cat plus, dog minus cat plus the fire engine equals fireman for that particular space. Like there's a bunch of things that can be associated in that space that come to have relational meaning, semantic meaning based off of their position. Like things get collected with like things, and then this unlike things get connected in the same way. So like cat minus dog plus, that movie with Robert De Niro, Meet the Fockers, because there was a bunch of cats, or that one cat, Jinxie cat, associated with that movie. That would not be as strongly associated with the dog. And it's a bit difficult to, right, and I'm not saying this as a cop-out, but it is difficult to acknowledge the difficulty in explaining any of these concepts, and something that I always try to work on, and because it matters to be able to break things down to simple, not simplistic, but simple terms for better shared understanding. So embedding here, and then it goes into, again, that vector database. You really just think of this as like a data vault, so that the model has a key to access. And so question, which is turned to that language, those tokens that the model wants and then uses, and these are for transformers. Not every model uses tokens, but transformers, 100%. Which then, right, they in this case had a browser, so they used the internet to augment that generation, so retrieving from the internet to augment the generation. And then they had some data sources that can be that, whether it's somebody with a PDF putting in there or that database that exists. I mean, ChatGPT right now has this at scale where they're turning everything into these little databases that you can turn on or turn off as a feature. That's what they mean when they say that it now has memory, because it's able to hold on to that. But that also takes up memory to have that database. So the more memory it takes up, well, then the more you have to spend for that. So yeah, just like anything else for storage. So, all right, and vectors, these are just those different representations of, think of, and that data point turned into a representation of just like the XYZ axis. So this data point over here, again, I'm not doing a great job of it, but think of like a little, one of the vectors that come out of this location here. So, right, that is a data point, 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 this being the y-axis, this being the x-axis. So different vectors, because they're different places that then the model goes and queries based off of whatever it is trying to get to then augment that generation of the answer. And so, yep, goes to different websites here, PubMed, UpToDate, and British Medical Journal best practices. And the fact that they use this encoder here, this text embedding, that is about 0.0001 cents per use, or per token, excuse me, per 1,000 tokens. It's really cheap, but not free. Or unless you happen to have like a membership, or like I have some credits for OpenAI through a starter program, and there are other ways of going about it. I mean, it's like very, very cheap. I mean, just like the point where unless you're using it as an enterprise use case, I mean, yeah, you'll more likely be fine. But it is something to be mindful of for folks, particularly institutions who are looking to take things in. Right, so language model, right, yep. Maximum length of 8,192 tokens. Again, for sake of conversation, token equals word. Query types, boop, boop, boop. And then their evaluation, right? And they look through, is it factual? Is it complete? And people prefer the actual answer. Yeah, says reply in precise configuration. I mean, yeah, that makes sense. Just because if every token costs some amount of money, because that's how a lot of these, most AI companies have turned or go for revenue generation, is charging per token. And again, it's like very, very cheap. We're talking like 1,000 tokens or 1,000,000 tokens for like 0.00001 cents. But it's not zero. So it's just something to be mindful of. Interesting that they highlight about adversarial prompting, and right, because we find that there are a lot of models that have, right, and we it's great that they acknowledge that there are going to be people are going to ask models questions that the model was not necessarily trained on, and that is, I mean, people ask each other things that they're not ready for all the time. And it's about being mindful of that and to understand that, oh, well, they're not supposed to use the model this way. Well, I mean, things happen. And so too, oh, that student wasn't supposed to do that, or why did they do this? Like, it's just one of those things. But the important thing is to just appreciate that it has that potential of people are going to try and poke at things. I mean, in the industry, we call it red teaming, but right. So here we have the evaluation here, good statistical significance, and right, going through heat maps, p-values for factuality complete, preference, and then of course compare Bard, ChatGPT 4, Bing, Almanac, right? And I'm going through this not because it's not important, but because there are over 600,000 models on Hugging Face, and Google doesn't even use BART anymore. That's now all Gemini. And they also have their MedPalm 2 model, which is the last medical one. They have MedLM now, which I haven't looked at all as of yet. So it's just more of like, these metrics are not necessarily going to be reflective of the current state. And that's just due to the speed at which things are changing, not because of anything of the folks in the study. But it is important, though, to again note that we're seeing that multiple people are coming up with these different answers, right? So they talk about the first MedPalm here, not the second, but that's a byproduct of the time that the study was done. And so it really is about, and this has become industry standard for grounding models in retrieval augmented generation. So this being from the NIH here, they had, and Hugging Face. Out of all the things to see in a paper, it just tickles me to be able to see that, right? And again, that Hugging Face, that French American AI company, is valued at like $4.5 billion with a B. So, I mean, and honestly, kind of into it in terms of the name, because it's very like friendly versus some of the AI terms are like GPT. It just seems a little aggressive, but I digress. So hopefully this was helpful in the standpoint of not wanting to poo-poo or to say that there is a right or a wrong way of considering what retrieval augmented generation, what generative AI is, how it should be used, what are the right protocols for training, deployment, red teaming, really any of that, because the reality is we're all learning together. I think what's most important, again, N of one here, is about acknowledging the fact that we're all working to find a good answer together, one that is cost efficient, that is energy efficient, right? And even to that point of, let's see, energy efficiency, the fact that it really is very, oh, no, not that one. I want to have, there we go. Every time we're doing something with AI, there is some energy cost. But so too are there costs in driving and using a blow dryer. And right, so even right now, in order to have clearer sound on this audio, and a few other things, I'm using one of my GPUs here, this NVIDIA RTX A6000, and I am very mindful of the fact that it is using 37 watts of power right now, as opposed to less of my RTX 4070 that's using 10 watts. And again, I'm not someone who's like, can I even turn it on? Like, no, it's providing utility, but it's something I'm mindful of because of the fact of you're seeing the folks having this feeling, this need, this pressure of, we have to build all this stuff and we have to things, and we need to get 50 H100 GPUs, and we need to make a supercluster, and we need to do all these, and so we can publish a paper and look prestigious and look at us, we're doing a thing. Like, okay, I mean, or if there's good awareness on what the use cases are going to be, which is going to be making small efficient models to help automate the mundane, the routine, to be able to parse and read and get information from PDFs and Word documents and PowerPoints, and really being just, again, helping people to get access to get more insight through their information, whether it's PDFs, Excel sheets, PowerPoints, whatever. Well, maybe there's not a need for 50 H100 NVIDIA GPUs that cost anywhere from between $10,000 to $45,000. I can't even keep track at this point. It seems unreal, but Maybe it becomes more of an A6000. One will do just fine and dandy, and or maybe a 4090 or Intel, whatever the GPUs that they're making, or Grok with the Q and the LPUs they're making, because the folks don't want to have an AI model on premises. It's just about understanding what the difference is in terms of what the use cases are, which more often than not is just, hey, we want to have AI assistants to help us do the jobs and retain our knowledge and make it accessible. Great, great. There's plenty of ways to do that. And right, if it becomes, oh, we want to have the best of the best because we want to accelerate drug innovation, it's like, okay, sure. Do you want to do it and feel the need to do it at the speed that, say, the Cleveland Clinic is doing it? Because they're using IBM System 2 quantum computer using liquid helium and all of that array to drive that level of acceleration. And sure, but most institutions don't have that money to do that. And so it becomes, how do we democratize quality intelligence access for folks? And it's about being mindful of with the right hardware, the right software, the right infrastructure for the right use cases, and understanding what the financial costs, emotional costs, and just right as people are trying to figure out all the skills that they want to develop and learn in a way that is fair and not overwhelming for learners and educators who are figuring this out in real time. So I think in the words of Ryan Holiday, ego is the enemy here. And it's about us all saying, all right, how do we team people figure this out? And rather than making pontifications or guesses on, oh, well, this probably isn't going to be fast enough, or this probably isn't going to be, it's probably going to be too expensive, or, well, this probably won't work. It's like, well, are you referencing the literature and making that comment? You know, the stuff, well, whether it's, you don't need to go to New England Journal of Medicine AI necessarily, but I mean, fire up the old Google and just pose the question, oh, well, is this thing already happening? Has anybody already solved that problem? Because I guarantee you, if you go to Hugging Face, again, just hilarious, and you look at the data sets and you look at the models and you look at just literally medical, boop, and you look at just picking one, and if nothing else, you look at how many people have downloaded that this month. 248,000 this month. So it's not a question of is this happening or not, or who's getting access to data. It's already out there. And for the question on intellectual property, well, intellectual property, I want to make very clear, do not advocate for people just being like, oh, I just go to Hugging Face and I can just take these data sets and no one can catch me, because it's like, no, that's not, don't do that. Or it's the point of intellectual property is about protecting the rights of folks for what they made, for the effort and time and energy and cost that they incurred in making a thing. It's understanding that there's so much information out there. A big part of protection with intellectual property is if somebody would file an injunction or indictment, depending on what court it falls into, if it's criminality versus more of the non-federal, non-super high-end space, but they have to show evidence and bring a case to a jury of their peers, or depending on how exactly the case is going, but with enough proof beyond a reasonable doubt that theft of intellectual property or improper attribution was done. think about how difficult that is within the generative AI space. I mean, even the New York Times, now they're alleging, or it's been alleged by OpenAI, the New York Times doctored and paid an outside agent to effectively hack into ChatGPT to be able to get it to make these prompts. And like, whether or not that was the case, the fact is that it is very, 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 very difficult and costly and time consuming to just think about putting all those things together just to bring something before a jury and say, we have undeniable proof that these people took this model. It's like, okay, good luck with that. Because, I mean, we've already seen this paper was published in January of this year. And already it is, I mean, there are so many more models than even just the medical space. And that's not even a year. And it's just going faster. So I am paying close attention to seeing what the United States Patent Office is looking at for standards, and also being mindful of, for my own processes and things. But I think the big thing is that now, particularly with generative AI, the moat isn't just about the best model, because best is arbitrary and can change on a dime. The best, and what I'm personally going for with Qompass, is aligning good, fast, and cheap, making accessible, quality models, having the processes be established and validated practices, whether it's retrieval augmented generation or the right training protocols, DPO, ORPO, SFT, FSDP, right? Just there's a plethora of them, but spending a lot of time mindfully looking through and seeing who did what, how did it work, what domains did it work, what domains did it not work, looking at the security posturing for those adversarial attempts that these authors highlighted. And right with that, cybersecurity being like Meta and NIST are really doing a lot of great things in that. I mean, particularly NIST, because of course, but even MITRE, one of the major cybersecurity institutions, is looking very closely into the space for generative AI and cybersecurity. So, MITRE, cyber, Gen AI. Yeah, so MITRE Atlas. Adversarial threat landscape for artificial intelligence systems. And seeing, I mean, this is for folks who have been in that security intelligence community space. This is very much, right, we have DefenseCon or DEFCON that goes on, black hats, that's probably like different, it's like a hacker term, and RSA being one of the most secure encryption protocols before all this quantum computing stuff really took off. So the point is that this is definitely, American non-for-profits, federally funded research on cybersecurity. So, all that to say, nope, not that one. It's really about understanding, having a good picture, having an accurate picture, not necessarily of keeping track of all the models, because that's impossible, but developing a view on when there's just something like a small tweak and when there's a shift fundamentally in the Overton window, whether it's the fact that the new Meta AI glasses can now interpret images in real time based off voice command, to the beginning of ChatGPT now having memory as a persistent feature, to even just the Open Medical LLM leaderboard that's now up on Hugging Face. And LLM leaderboard. That by itself isn't necessarily a big shift in any one particular model, but the fact that this now is openly available, and from Open Life Science AI, not familiar with them, but University of Edinburgh, National Language Processing, and of course Hugging Face. I mean, right, just like the emoji. So the fact that there will be people who see this as this is now the new benchmark, and in fact this is from Hugging Face. So again, had that industry academic partnership, but I think we even acknowledged that the Stanford was it Human-Centric AI Lab? They just recently published that index, and it highlights how much of a difference there is in the amount of innovation coming from industry versus the innovation coming from academia. And I'd even go further in saying that there's what's happening in academia and there's happening in not academia. Just from the standpoint of how low the barrier is now for folks who want to go out and solve a problem, and not just about research and development, but about research and delivery. So doing research, which is asking a bunch of questions and finding data, finding proof, testing a hypothesis, and then from there building a solution, delivering a solution based off of those things and putting it to the community, whether it's PubMed or preprint like arXiv, medRxiv, bioRxiv, but making it where you're solving these big questions, big problems in a way with expertise that you either have or that you develop in real time. So hopefully this was, again, waxing a little poetic here, but I think that it's important to view these different topics, these industry terms, whether it's retrieval augmented generation, even just AI ML, from a standpoint not of, oh, this is the right language, this is the right thing to say, this is the, oh, you didn't say this term, therefore you don't know what you're talking about. So we're all learning here. Everybody's trying, but it's important to be communicate and be accurate, when as much as possible, to be precise with good intention, and then understand when the data, significant data, not just one-offs, not just, oh, well, here's one thing it didn't do, but significant data, robust data, mixed data, shows that, hey, we were wrong, to be able to let that ego go and say, yep, we were wrong. We thought it was this, but we were wrong. Somebody else solved that. So now this is the reliable, better way of doing this. It's not about sexiness. It's not about, plenty of the stuff is sexy, but it's about highlighting what works, what makes sense, what's sustainable, what is going to be something that everybody can use that will deliver on the promise of quality, amplifying human intelligence. Because otherwise, well, it's just more pontification, more blah, 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 that you see in all of these different conferences, things. I'm not trying to poo-poo the conferences for what they are, but it's the concept of publish or perish in academia is a real thing. And so it's just about acknowledging that for what it is and seeing this new shift that's happening when we ask that question of, well, what works? And I'll show up with our evidence saying, hey, this is what worked for me, and being willing to have it put out there and tested and trialed and be proven wrong. And that, I think, is going to result in just a lot better answers, a lot better solutions, and really great innovation we're looking forward to. So I'm hopeful that this audio now is much better. Appreciate the input I got back, and also I'm using NVIDIA RTX broadcast to do this, as well as getting a better microphone. So I will not be making them quite as long next go around, but again, for the important things, it is important to deliver on accurate information that is simple but not simplistic for folks that anybody can understand. All right, until the next one, take care.